Thank you very much, Kirsten. I've never been to Hawaii, and now I guess I want to go even more than ever. And hopefully I'll have a chance before. No, I keep the faith. Just remember that. Our next presenter, always really good to see that we have a really interesting mix of kind of flavors of topics. Jake came into the program and had a really broad range of interests, and I think this project will speak for itself, but he picked up on data analysis really quick, and I have a strong suspicion that he's going to stick with the in some capacity with this data analysis, whether it's in geophysics or some other application. But you know, every year, so there's like somebody, they're really gonna make this pivot from this to like a hardcore quantitative, possibly a quantitative like database career. This Jake just has a gift for this, and I was very impressed by, you know, a lot of PhD mentors will, you know, first 6 to 9 months in the program just kind of get comfortable, go to class, make a couple figures. I think, you know, I think like a mentor would be like, wow, you had a productive first year just seeing some of the slides that Jake made here in the context of an MAS project. So a lot of potential in this student and a really interesting project, Drivers of Oxygen Variability in the Northeast Pacific. Jake Tidwell.
Thank you, Corey, for that introduction. Okay. Sorry, I can't find the, yeah, sorry.
Tough to find it.
Yeah, where is it?
Right here.
Oh, right there. Oh, perfect. Thank you. Whoops. Okay, thank you guys for being here. Sorry for that delay. So my capstone project was on Northeast Pacific oxygen variability in a warming world. And before I get into it, I just want to do some brief acknowledgments. So I don't come from a STEM background. I studied anthropology in my undergrad. And I want to say a really big thank you to my capstone chair, Yasir Edabar, for his mentorship and for introducing me to the tools and methods for doing oceanographic research. And I also want to thank my other committee member, Jack Ewing, who's a really good friend, and he inspired me to pursue this degree and provided endless support along the way. And also to my friends and colleagues in the CSP program. You guys have been awesome and just amazing people. So I want to get started and just kind of talk about what the ocean means to me. So growing up, my dad used to dive for red abalone off the coast of California. And as a kid, I remember him bringing back these giant mollusks and showing me how to like cook and clean them. And I remember like holding these like iridescent shells and looking at them and wondering what it would be like to swim through a lush forest of kelp and dive down and look for these abalone. And he promised me that when I was old enough, he'd take me out and teach me how to do it. And in 2014, around the time I was old enough, a major marine heat wave actually came through and decimated a lot of marine ecosystems and resulted in a closure of the red abalone season that to this day remains closed. And this was kind of the first time I remember asking some of these questions like, man, what is a marine heat wave? Well, you know, how do they form and what is this climate change thing? So I didn't get to dive with my dad, but we did do a lot of fishing, and we went up to Alaska and, you know, off of the North Coast. And as I kind of, you know, learned how to fish, and I started asking different questions like, you know, how come the fish aren't in the same spot they were last year? Or why do we have to go further out for the same catch? Is it because we're over-harvesting, or is it because of some other physical process happening in the ocean that's affecting the species ranges? So then I came to Scripps, and in the summer we got to go out on the Sproul and collect our own data and tour the Argo Float Lab, and I was getting exposed to how researchers go about answering some of these questions. And we got to use some of the data we collected on the Sproul in a project about oxygen variability. And these are some figures from that presentation that Hadley made. Thank you, Hadley. And basically what we were doing is we were comparing our CTD casts with other casts in the same area. And what stands out here is the relationship between temperature and oxygen. So it seems like when the water was warmer, there was less oxygen. And I kind of wanted to keep exploring this question in my capstone about how climate change and ocean warming is impacting ocean oxygen levels. And it turns out that it's actually, oh shoot, oh no, there we go. Turns out climate change is causing a long-term decline in oxygen in the global ocean, and increased warming reduces oxygen solubility and increases stratification and impacts circulation patterns. And a study by Schmidt-Co et al. In 2017 estimated that there's been a 2% loss in the global ocean since 1960. And another study in 2020 used Ocean Station Papa data. And Ocean Station Papa is a really important mooring array in the Gulf of Alaska. It actually has one of the longest continuous time series of oceanographic data in the world. They've been collecting data since 1949, which is awesome. And they use that data to estimate that there's been an 11.7% loss in the Northeast Pacific since the 1960s. So this kind of made me wonder, like, why is there so much variability between different ocean basins and different depths, and what are the drivers of that variability? And so this figure kind of breaks down the drivers of oxygen variability into three groups: the global scale, basin scale, and regional scale. And we just talked about global warming and its impacts. And aerosols, whether they're from humans or from volcanic eruptions, they can actually cool the surface of the ocean and temporarily increase the solubility of oxygen. And then going down to our basin scale processes, we have our normal climate modes like the El Nino Southern Oscillation, Pacific Decadal Oscillation, and marine heat waves actually fit into these basin scale processes of kind of interannual variability. And then going over to our local processes, I really wanted to focus on mesoscale eddies, which are these swirling vortices that form off larger currents, and they can be 10 to 100 kilometers wide, and they typically last months to years. And they have a significant impacts on ocean biogeochemistry and mixing, and that's something that I really wanted to focus on. So the map behind this graphic shows model output of dissolved oxygen, and scientists use models like this to simulate the Earth system and project how the ocean and climate might change in the future. But there's some constraints. So resolving some of these faster regional scale processes like mesoscale eddies require a huge amount of computational power, and many models still can't simulate them directly over a large scale. And we also don't fully understand how eddies impact oxygen and some of these other biogeochemical parameters. And so I kind of like to think of our current models like looking through one of those frosted windows and trying to tell what's in somebody's yard. You might be able to see or like make out the shape of a tree or a fence, but you can't tell what kind of tree that is or what the yard really looks like. And so to sharpen that view and improve projections of climate change impacts, we need to resolve for these eddy processes more accurately, and that starts with high-resolution ocean observations. And so this map is just kind of orienting us to where I was doing my research, and this is showing that Alaskan current as it kind of moves up the Alaskan coast, and Sitka is actually a place where my dad and I used to fish. And Ocean Station Papa, that mooring array I talked about earlier, is located right there, and it's an absolute treasure trove of high-resolution data. And so what Ocean Station Papa is, it's basically just an array of 3 moorings that have different instruments and sensors, and the one that I focused the most on was the vertical wire following profiler, which is basically just a continuous CTD cast that takes ocean property measurements. And then the Ocean Observatories Initiative, they kind of run this operation, and they deploy gliders, which are autonomous underwater vehicles that go between these moorings and go up and down the water column. And they're really awesome. They provide a lot of awesome data. And then I also use Argo floats. So another thing that I used was the gridded ocean biogeochemistry from artificial intelligence, GoBio2. And this basically just uses machine learning trained on Argo float and ship-based observations, and it uses random forests and feed-forward neural networks. Don't ask me what that is. I know it works. But basically, it's interpolating between these observations and can provide a monthly oxygen field from the surface to 2,000 meter depths at a 1 degree resolution, and kind of fills in some key gaps in the interior ocean oxygen. Okay, so now we're going to kind of jump into the basin processes, and I focus mostly on heat waves. Because between 2013 and 2023, the region experienced some of the most extreme climate events on record. There was that heat wave in 2014, and then another heat wave in 2019 that got a little bit less attention in the press. So I wanted to see what these heat waves were doing to oxygen in the water. And so this figure, I generated it by selecting a 10 by 10 degree grid in the GoBio2 around Ocean Station Papa and removed the long-term average to get temperature and oxygen anomalies. And then I followed that same 10 by 10 degree method for chlorophyll data that I got from the Copernicus Global Biogeochemistry Hindcast dataset. And this is basically just a time series from 2004 to 2022. And that top panel is showing our temperature anomalies. And you can see during our heat waves, we have a really high, positive temperature anomaly. And then in the chlorophyll panel, we see some strong negative anomalies in the upper 50 meters during both marine heat waves, and that's likely due to some increased stratification and maybe some reduced nutrient supply. But then below the mixed layer, there isn't much of a clear pattern. There seems to be a lot of variability. In the 2019 heat wave, there seems to be some positive anomalies below the 100 meters, suggesting like maybe there's a deeper chlorophyll maxima or something going on there. But I think the panel that's most interesting here is the oxygen panel. And during both of these events, we can see some surface deoxygenation happening. And this is actually consistent with previous research by Samuel Milgan in 2022, who found that during that 2014 heat wave, there was a 3% reduction in oxygen in the surface layer. And we see a similar pattern in that 2019 heat wave, which could support the hypothesis that oxygen loss in that upper mixed layer is ubiquitous between different heat wave events. But I think more research is definitely needed. And then looking below the mixed layer here, we can see some differences. So during that 2014 heat wave, we see a strong negative anomaly. And in our 2019 heat wave, we see a positive anomaly. So this is indicating that maybe there's something else going on that's affecting oxygen besides just our heat wave. So I wanted to kind of take a look at what the Pacific Decadal Oscillation is doing. And during that marine heat wave in 2014, there was actually a warm phase in the PDO. And during that warm phase, the thermocline is usually deeper than, and that deeper layer blocks nutrients from rising to the surface and can lead to lower productivity in the upper ocean, which means that less organic matter will sink and less oxygen will be used up. So we would actually expect to see a positive anomaly at depth during our 2014 heat wave, which doesn't seem to be the case. So this is maybe suggesting that PDO might not impact open oceans as much as coastal waters, or maybe there's some other physical processes that is driving this variability, and it just kind of opens the door for more research in the future. So now we're going to kind of dive into the local processes, and I looked at mesoscale eddies. And the way I did that, I located and tracked eddies using the Meta 3.2 Aviso Plus eddy tracking dataset, which uses satellite altimetry to locate eddy instances. And I wanted to see when or if eddies were actually passing through Ocean Station Papa. And so this is just animation of an eddy that formed off of that Haida Gwaii archipelago off the Alaskan current. And these eddies are really important in the Gulf of Alaska because they trap warm and fresh coastal waters and transport it offshore, and they sometimes last up to 5 years, which is really long compared to typical eddies. And right there, you can see that this eddy actually did pass through our station, but it didn't make a direct pass. So the moorings only sampled the periphery of the eddy. So aside from transporting warm, fresh water, they also have been shown to carry like high iron and high nutrients, and they're really important for primary production in the Gulf of Alaska. So this is just kind of showing what's happening at the surface, but these eddies are three-dimensional structures, and so we wanted to see what was going on in the water column. And so this is from the vertical wire following profiler at Ocean Station Papa, and it's showing oxygen from 250 meters to 2,000 meters. And it's really high resolution, which is it's awesome. And we can see what looks like a slight injection of oxygen into the deeper water column, and that could be a signal of our eddy, which is typically associated with downwelling water from the surface. But there's a limitation here, so this is only sampling from 250 meters to 2,000 meters, and a lot of the eddy impacts are happening in that surface layer. And so we were really lucky that there was a glider that actually sampled at the same time that this eddy was passing. And so we were able to see kind of what's going on at the surface down to 700 meters. So this glider anomaly, I used the GoBio2 data set and extracted the 1 degree grid point nearest to Ocean Station Papa and used it as the local climatology to just subtract and find our anomalies. And what this is showing is this eddy actually had a colder water and a higher amount of oxygen. And this is not what we would expect, because typically these anticyclones have warmer water. And so this cold anomaly kind of threw me off. And it could be an indication that it was trapping colder waters at the coast and then propagated that out to the open ocean, or it could be an indication of some sub-mesoscale processes that were going on. But I think what's important here is when we're comparing this to what we saw during the heat wave, this eddy could actually kind of be like modulating the impacts of that heat wave. So I wanted to see what other eddies were doing, and I was able to locate 3 other instances of eddies passing over Ocean Station Papa, but they all fell within some unfortunate data gaps in the wire following profiler. So I had to kind of change course. And what I did is I used the same collocation method with Argo floats. And so this animation is just showing an Argo float in green, and then there's your anticyclonic eddy that formed. And that float got picked up by the eddy and did a couple of anticyclonic rotations, and the whole time it's just like profiling the eddy, which is really awesome. And then these figures over here are showing what the Argo float picked up, and we can see what looks like a pretty clear anticyclonic signature, just kind of showing that downwelling of warmer waters to the deeper layers. And then we also have a really striking oxygen anomaly. And this eddy was in 2022, so it's not associated with the heat waves. But I'm not exactly sure what to make of this negative anomaly, and these are just preliminary results and some ongoing work. But what I wanted to do is kind of put together an inventory of all of the instances where Argo floats were sampled, or eddies were sampled by Argo floats. And I wanted to provide this inventory as kind of a stepping stone for future research. So if anyone else is interested in like looking into these eddies in this region, they can use this inventory and just pick up from where I left off. And this is expanded, so I included the California current system in there too. Cool, so before I get to my summaries, I just wanted to provide some recommendations for future California current system observations. So this is already a really highly observed region, and there's some amazing moorings operated by the time series group here at Scripps. But I think implementing a complementary mooring with a high-resolution wire-following profiler would allow us to start analyzing the biogeochemical impacts of eddies in the California current system. I think it'd be awesome. And so then to summarize, marine heat waves in the Northeast Pacific have variable impacts on ocean oxygen, and mesoscale eddies not only drive additional variability, but they may also modulate those impacts in the open ocean. And this work highlights the need for continued high-resolution ocean observing and raises deeper questions about how eddies interact with global and basin-scale climate modes. And these observations are essential for understanding cross-scale dynamics and improving climate models that aim to predict how the global ocean will respond to a warming world and maybe predict where the fish are going to be next year. So, yeah. Cool. Thank you, guys.
How did you determine which eddies to look at and like go through that?
Yeah, so I wanted to make sure that the eddies we were looking at were actually coherent structures and impacting the water column. So I applied a filter of a minimum lifetime of 10 days, minimum diameter of 40 kilometers, and a minimum amplitude of 2 centimeters. So that's, yeah. Hadley?
In terms of like future projections, have you seen data about like long-term deoxygenation, and like is that projected to get worse as climate change impacts these systems more?
Yeah, I think it seems to be the case that it's going to continue to decline. But we kind of need to unravel like everything that's going on, and yeah, there's a lot of things impacting the variability. Yeah, thank you.
I was just wondering what your biggest takeaway from your project was and what you would like to see in this field of research next, like the next steps you'd like to see in the future, either taken by you or other scientists.
Yeah, I think the biggest takeaway is that these eddies could be modulating the impacts of these extreme events, and I think I would love to see just continued research on these eddies and how they're impacting things, and yeah, thank you.